Welcome guys to episode of Next. Today we're going to be doing deriving the rocket equation. So first, let's start with defining a few variables for this question. So let's say the exhaust gas velocity of the rocket is going to be mu, m meters per second. That's going to be the exhaust velocity of the fuel. And let's say the rate of the fuel being ejected is going to be alpha, kilograms per second, right? So now we can get a few things out of this. So let's first draw two frames of the rocket. One is when it's in the air moving, right? So let's draw the rocket, thrusters. Let's call the total mass, the mass of the rocket plus the mass of the fuel, to be big M, right? And it's going to be moving, say at a speed of v. And now in the next instant of time, well, it's going to eject some mass out, right? It's going to eject some mass this way with a speed of mu. Let's just call this mass delta m, right? Because for instance of time, if the change of mass is alpha, then the delta m will just be alpha times the delta t, right? So this mass, the mass of the rocket combined, right? So it's going to be mass of the rocket, total mass minus your delta mass. Let's say just total mass, right? Total mass is just mass of the rocket, which I call m only, plus the mass of the fuel is going to be m naught. And now this is going to be moving at a velocity of v plus some delta v that you get from the thrusting of the fuel. The fuel is not moving at a velocity of mu, right? Because that's just the velocity coming out of the rocket. In another frame of reference, it's going to be v minus mu. That's the frame of reference, right? So let's just calculate the momentum of each frame, each scenario. In the first scenario, the momentum of the first one, let's call it P, momentum of the initial situation, is going to be total mass times velocity, right? Now the momentum of the second situation is going to be total mass of this, right? Let's calculate the momentum of the rocket and the momentum of the fuel and add them together. So it's going to be total mass of the rocket minus the mass ejected times your velocity plus your delta velocity gained from thrusting these fuel. And then you add to it the fuel's momentum is going to be v minus your mu, right? Because that makes sense, right? You're going at v, going down at mu, so it's v minus mu. Oops. Let me fix that. You're going up with v, right, already, but then you're thrusting down with mu. So your velocity is going to be v minus mu, right? Hope that makes sense. All right. So now if you expand this equation, you get big M v plus m delta v minus delta small m v minus delta m delta v. And add plus this, it's going to be plus delta m v minus delta m mu. Now you see here, some terms can cancel out. Let's see. Delta v, no other delta v's. Delta m. These two terms can cancel out. Now you're left with mv plus m delta v minus delta m delta v minus delta m mu, right? Now you know from like grade 11 physics, right? The force momentum relationship. Your change in momentum is going to be the external force on the system over your changing time, right? So let's do that. This is initial, this is final, right? So let's do final minus initial. So change of momentum is going to be this thing minus this. So you see, mv, these two will cancel out. So your change in momentum is going to be big M delta v minus delta m delta v minus delta m mu, right? Three terms. And this is going to be equal to your force external, which in this case is just going to be mg, right? Oh wait, I made a mistake, my bad. It's not supposed to be like this. It's your force external is going to be your change in momentum over changing time. So this is going to be over big delta t. And your force external, right? The gravity acting on the rocket is going to be downwards of magnitude mg. So because the reference frame is upwards, it's going to be negative mg for our case. So negative mg. Now, if we take t as delta t goes to 0, right? So you convert everything to infinitesimals, you can see that negative mg is going to be equal to, let's see, v, right? Make it dv, so it's going to be m minus delta m, right, like this. Now delta v becomes dv divided by dt. And then here, right, it's minus mu dm over dt. Now this looks pretty similar to a rocket equation already, right? So now we can see from beginning, right, your delta m is going to be alpha delta t. So delta m here is going to be alpha delta t. So set that in first. So negative mg is equal to m negative alpha delta t dv dt minus mu dm over dt, right? So now we can also see that if you take the limit of delta t to 0, this term will just disappear, right? And now we can see now in the beginning, right, your mass is just going to be this plus that, right? And then after a certain amount of time, your mass is just going to be m minus delta m, which is the mass here, right? The mass here, the mass here. This is going to just be m minus alpha t, right? Alpha delta t, but that's not important for now. So I'm just going to replace that here, right? So negative m minus alpha t g equals to m minus alpha t dv over dt minus mu. This is what? This is dm, right? Changing m. dm is equal to basically changing m. And changing m is just alpha delta t. So we have basically mu alpha dt over dt. And the two dt's cancel, you just get mu alpha. Right, so this looks pretty similar to a differential equation already. If we isolate for dv dt, let's do that right now. So we put this there, so we get negative m minus alpha t g plus mu a, right? It's going to be equal to this thing, but you subtract that, and then you divide that down here, and you get dv dt. You also notice that this term and this term are the same, so you can write it as dv dt is equal to, these two cancel out, right? So negative g plus mu alpha over m minus alpha t, right? This is our differential equation. All right, now that we finished founding the differential equation, deriving the differential equation, we can solve it to find the velocity and the height of the rocket at a given time, right? So we can solve this using a computer, but I'm just going to show you how to do it manually because this is a tutorial. So let's first, we just integrate both sides, right? dv, and you move the dt over the other side, so we just get mu alpha minus your mass minus alpha t minus g, right? Yeah, okay, so it's going to be dt, right? So here, this side is going to be v. Here you get integral of mu alpha minus mass minus alpha t dt, and gt is just going to be negative gt, right? Now here, you can do a simple substitution, right? So I'll just do it in my head for now. So we can get, actually I'll write it off so you can follow along. So let's get u equal to mass minus alpha t, right? And then you get du equals to negative alpha dt, right? So now I can just plug that in. Take alpha at, you take the mu out, put a negative sign inside as extra to compensate for this one. And you get put alpha as part of this, so you get d mu, so you get du 1 over u du minus gt. And I can just integrate it as a long function, so negative mu is going to be ln absolute value of u, right? But absolute value of u is just m minus alpha t. So you plug that back in, and you get minus gt. And now you integrate it, right? You got to get a constant integration. So we know at v equals to 0, your t is equal to 0, right? At t equal to 0, v equals to 0. So you get 0, v0 equals to negative mu ln a alpha. Alpha t is 0, right? So ln m minus gt 0 plus c naught. C naught is equal to 0, right? So you find that c naught is actually just equal to, put that over there, negative sign, cancel out, mu ln m. I'm actually bad at writing. Okay, so your v is going to be negative mu ln m minus alpha t minus gt plus mu ln m. But you're going to combine these terms, right? If you want to combine this, you're going to make a minus here. So you can, so it's negative mu here, this can go into here. So you get negative mu ln, it's going to be a negative sign, right? So you use log law, or ln law to be precise. So minus t, ln law, right? Subtract is divide. So subtract, divide is m, right? Minus gt. So here is your final equation for the velocity, right? Velocity v equals to negative mu ln mass minus alpha t over mass minus gt. Right, so now we want to find height, right? Height is a bit complicated because, well, one thing, you have to integrate this big bra. So let's do that. The integral of dv dt is going to be the integral of this thing. Well, let's first take the negative mu out, because I don't want to deal with that right now. Nobody cares what this is. So it's ln mass minus alpha t over mass dt minus gt squared, minus gt, integral of dt, right? So minus gt is just going to be gt squared over 2. That's going to be the integral of this thing. So now we're just going to focus on this thing. So let's just zoom out. Let's not worry about the entire big picture. Let's just try to solve that integral. So your integral is going to be ln mass minus alpha t over mass, right? You get that right? Yes, mass minus alpha t over mass. Right, okay. Now, how would you solve this? How would you solve this? Yeah, okay. So, first, let's just try u substitution. U equals to mass minus alpha t over mass. And now you get du equals to negative alpha over m dt. You put negative mass over alpha ln u du. Now you get negative mass over alpha, well, ln u du, right? So how would you get rid of ln u du? You got to take out derivatives here somewhere. So just split it up into imaginary ln u du times 1, and let's use integration by parts. So first, we have to integrate. We have to integrate this once, right? We have to integrate this thing. 1 is going to be u. And then you just leave ln as it is. And then you subtract the integral of the derivative of this thing and this thing as it is. And this thing integrated, right? Integrate this, leave it as it is, derivative of this, integral of that. Yeah, okay. And you put ln derivative, right? It's just 1 over u. And put this as it is, du, right? And now you just get negative mass over alpha. This is going to be u ln u minus, this is just going to be 1, right? So it's just minus u. Now if you want to plug everything back in, you get negative mass over alpha, mass minus alpha t over mass, ln mass minus alpha t over m, minus mass minus alpha t over m. That's your first thing solved. Now if we want to plug it back to this equation, right? Let's rewrite that here. We can see if I memorize it. H is equal to, I can't memorize it, negative mu, and the integral, I'm just going to signify the integral as a square because I really don't want to write that out again, minus gt squared. This thing is the square, right? So just plug that in. With negative u, so negative signs cancel out. You get mu mass over alpha. Your integral, in this case, is going to be mass minus alpha t over mass ln mass minus alpha t for mass minus mass minus alpha t for mass. All right, get the idea. And minus gt squared. But don't forget, you're going to get constant integration here. Let's call it C2. I skipped C1, but nobody cares, right? All right. So, my God. All right. So, now we got this covered, right? We can just see. Have M here, out of here, out of here. Also M here, out of here. All right, so we get mu alpha is equal to m minus alpha t ln mass minus alpha t over m minus m plus alpha t. Wow. Minus gt squared plus c2. Yes, I use square bracket here and curly bracket here. I don't care. All right. So now at time equal to 0, right? H is going to be equal to 0. Let's try that. So h equal to 0, equal to mu alpha. T is gone, so just m ln t is also gone, so m over m minus m plus alpha tt is gone. Aha, I did it again. Minus 0, right? Plus c2. Now, you see, ln m over m is this equal to 1, right? Everybody knows ln 1 is equal to 0. So this term is just gone. So it's just going to be equal to this. So let's put negative c2 over here. It's going to be equal to mu alpha negative m. Right, so cancel, cancel. Your C2 is going to be equal to mu alpha m. So if you plug this back into your H equation, H is going to be equal to mu alpha, I'm going to start with the curly bracket this time, mass minus alpha t. Let's end with a square bracket, ln mass minus alpha t over m minus m plus alpha t. Let's end with a bracket minus, do this thing. No, we're not taking the average. I'm just writing curly pointy bracket as the, just because we're not taking the time average. Okay, so plus C2, right? Alpha m. Right, so this looks pretty nice. So I'll take this, right? Alpha m, alpha m. So let's get rid of that. Put the m in here, inside, plus m. Oh wow, look, there's negative m plus m. They cancel out nicely. Very nice. So we're going to get mu alpha. All right, we're going to write it in actual nice format now. T ln m minus alpha t over m plus alpha t minus gt squared over 2. Oh, looky here. I forgot a 2 down here. I forgot 2 everywhere. Okay, I'm actually clowning. All right. Now, just in case, we want to put the, let's expand this and put the m back here because you can express it in easier terms. Let's put mu m alpha. It's going to be mass minus alpha t over mass, right? Ln mass minus alpha t over mass plus alpha cancel out ut minus gt squared over 2. Right. So now here you can also write the mass minus, because this is just your beginning mass, right? This is your beginning mass minus your delta m. This is basically, okay, I'm going to do it somewhere here, out of space. M minus alpha t over m, right? This thing is just your beginning mass, your start mass at the beginning. And alpha t, this is going to be your negative delta m, right? So this is basically your mass at a function of time divided by your total mass. So this is your percentage mass at that time. So you can just write it, this big thing, as like one single random variable. Let's call it beta. Now you can just simplify it a lot. So h is just equal to mu mass alpha times your random beta ln your random beta plus mu t, right? Is that mu t? And then minus negative g2 squared, yes. Minus g2 squared over 2. And this is your, basically your Rocky equation for your distance in the sky after a certain t, given your beta, and then your mass of the exhaust, and your rate of the exhaust, and your gravitational constant and whatnot. And up here, let me find it. Yeah, supposed to be up here. Yes. No. Yes, here. Here is your velocity at some random period of time, given your speed of the exhaust. So this can be substituted with the b as well, and minus gt. And that's enough for today. See you guys later. Bye. でもそんなんじゃダメもうそんなんじゃほら心は進化するよもっともっと